Hello, science fans, and welcome to SHE-ensya. Why do we go hungry? Why do we even get bored? Why did we evolve to have religion? Why is makeup part of human culture? Why are babies so cute? Why do we think that aliens exist? Why do we ask questions? The SHE-ensya Why series will dissect some of our most head-scratching why questions, teasing out the scientific principles from historical records, conspiracy theories, and mass media. Join us in today's episode as we ask the question, why death? I find myself wondering about humanity. Their attitude to my sister's gift is so strange. Why do they fear the sunless lands? It is as natural to die as it is to be born. But they fear her, dread her. Feebly, they attempt to placate her. That was one of my favorite lines from Neil Gaiman's The Sandman series, where Dream, the main protagonist, expresses his concern over humans' attitudes towards his sister's gift, death. It was very interesting that Neil Gaiman depicted death as a young, charming, optimistic woman with the most balanced personality, and the only give to popular conceptions of death is her all-black, often gothic outfits. In the series, death typically wears an ankh, an Egyptian symbol referred to as the key of the Nile, and is also a symbol of eternal life. Though the ankh has always been associated with life, the sun, fertility, and light, it figures so prominently in tomb paintings and inscriptions. Deities such as Anubis or Isis are often seen placing the ankh against the lips of the soul in the afterlife to revitalize it and open that soul to a life after death. The concept of life after death, even the thought of heaven, represents the efforts of human society to make death a little more appealing. All Souls Day, Dia de los Muertos, and Halloween are holidays designed to give us time to remember those who passed away, to make death less grim, and also make light of some of the more gruesome aspects of death. But despite this, for most of us, the thought of death is not pleasant, and most of us would avoid such morbid musings and would focus instead on what life has to offer, perhaps our own wishes and goals. The fear of death is referred to as thanatophobia, deriving from the ancient Greek words thanatos, the name of the god of death, and phobos, meaning fear. Notably, thanatophobia, which is called death anxiety in a clinical context, is not listed as a disorder in its own right. Still, this rarely spoken about anxiety has the potential to seriously affect people's lifestyles and mental health. Thanatophobia was first tackled by Sigmund Freud, who did not consider it to be fear of death as such. Freud thought that we cannot truly believe that death is a real occurrence, so any death-related anxieties must stem from childhood-related trauma. But it was a theory put forth a little later by an anthropologist called Ernst Becker that ended up informing most current understandings of death anxiety and its causes. Becker believed that death anxiety comes naturally to all individuals who find the thought of death as unacceptable. That is why he argued everything everyone does, the goals we set, our passions and hobbies, and the activities we engage in, is, in essence, a coping strategy, and that these things we focus on so that we do not need to worry about our eventual death. Becker's work gave rise to the terror management theory, which posits that humans must consistently face a battle within ourselves, our desire to live versus the inevitability of death. The terror management theory emphasizes individual self-consciousness and their drive to achieve personal goals motivated by the awareness of mortality. According to the terror management theory, self-esteem is key to managing death-related anxieties. Individuals with higher self-esteem can deal with death anxieties a little better than those with lower self-esteem. As an alternative explanation for the fear of death, there is also the separation theory, which highlights the importance of early trauma reinforced by an awareness of mortality later in life. But then quite recently, the post-traumatic growth theory was also established. Here, it explains that a distressing event, such as the death of a loved one or a troubling medical diagnosis, can actually have a positive effect, such as a person appreciating more the little things in life or even becoming more goal-oriented. Considering all the anxiety and fear it causes, there has been a lot of work on trying to slow down or avoid death altogether. Many believe that the key to extending lifespans is curing ailments, but life expectancy only increased significantly 100 years ago or so. And contrary to popular belief, this change had little to do with modern medicine. The key human advancement that extended our lifespans was sanitation. When people discovered the effect of microorganisms and other pathogens to our health, the simple acts of hand washing, boiling water, and making sure food is clean before eating it made a huge impact in prolonging our lifespans. Over time, countries also got better at distributing food, which decreased instances of starvation. And though we have experienced acts of terrorism and violence since World War II, the implementation of relative peace and order since that war has lessened violent crime by at least 25%. But in a future with no violence, no illness, or no hunger, will death still exist? What does science have to say? The biosphere and its many ecosystems rely on more than just life processes to subsist and exist. Death and regeneration are a necessity to the flow of the biome. A biome is a naturally occurring community of plants and animals occupying a specific space. And for now, until we discover another planet containing life, Earth is the only known biome to exist. But, going back to death, in 2013, Dr. Eric Benbow of Michigan State University coined the term necrobiome, which is a collective of organisms that assist in plant and animal decay. Necrobiomes ensure that nutrients are recycled and returned to the soil, so that new life can spring from it again. Death also plays a role in preventing or minimizing overpopulation. Most organisms exhibit a population growth range described as logistic. In logistic growth, a population's per capita growth rate gets smaller and smaller as population size approaches a maximum imposed by limited resources, often called the carrying capacity. When the population growth slows down or appears to stop, this doesn't mean that no new children are being born. It just means that the birth rate has achieved balance with the death rate. And here we can see that death makes sure that the population size is controlled in such that the organisms only consume what the earth can replenish. But even with death still plaguing the human race, we are experiencing an exponential growth rate which is causing us to clear more wildernesses and to harvest more resources than the earth could regenerate. Quite recently, a new documentary by David Attenborough was released on Netflix, and its title is Life on Our Planet.
Tonight, we've got a rather different program for you.
The living world is a unique and spectacular marvel. Yet the way we humans live on Earth is sending it into a decline.
It made me realize that as we are stuck at home due to a pandemic that we caused because of our continuous destruction of natural habitats for organisms, causing them to live more closely with us and thus allowing for the transfer of viruses such as those that caused COVID-19 to humans, made me realize how depressing it really is that we have even less time to experience the beautiful wildernesses that we still have. And their disappearance is more than just cosmetic. It's actually a signal that the earth is transforming into a place that will be less and less livable for our species. And thus, without a balance between life and death, reality will devolve into chaos as resources remain finite. But what if resources become infinite? Can we then try and live forever? Before that could happen, we must first combat the biologically programmed process of aging and death within our genes. Because you see, as we live through our daily lives, our cells produce highly reactive chemical byproducts that result to wear and tear and eventually cell death. When cells use oxygen to generate energy, when they encounter stress, when they're exposed to sunlight, when they're exposed to toxic substances that we are addicted to, free radicals are created as a consequence of ATP production by the mitochondria. Free radicals are highly reactive substances that disrupt the structure and function of lipids, proteins, and other chemicals within our cells that can result in disease and even death. If free radicals overwhelm our cellular systems, it results to aging and damage. Luckily, there are such things as antioxidants, and these are substances that can prevent or slow damage to cells caused by free radicals. Our bodies naturally produce antioxidants whenever we rest, relax, or even meditate. However, if these things are not possible, we can also consume antioxidants from healthy foods such as fruits and vegetables. And again, if that's not possible either, we can also drink them through supplements. But no matter how much we contradict the actions of free radicals, eventually our cells would perish and would need to regenerate. And it is in this process where aging and death are integrated in our genes. Because you see, the process of DNA replication is imperfect. It is only capable of copying a certain percentage of your genes, and its tips, the regions called the telomeres, are slowly sheared away over time. The slow removal of the telomeres are not immediately felt because they are non-coding portions, meaning they do not represent any functional proteins. But once the telomeres are gone, the portions removed could be essential genes necessary for our proper functioning, and without them, we get sick and die. Counteracting the shortening of our telomeres is an enzyme called telomerase that over time replaces the lost telomeres. However, its action is much slower compared to the imperfection of the DNA replication process. So, it is currently insufficient to stop cellular aging or even death. The only instance where telomerases have functioned sufficiently to prevent death and aging can be found in cancer cells. Ironic, isn't it, that the key to our immortality is found within a disease that kills almost 10 million individuals per year. And so, science has spoken. The concept of life after death may be an important psychological tool to overcome the paralyzing fear of death. The fear of death is called thanatophobia or death anxiety. The fear of death has been linked to childhood trauma or self-esteem issues, but it can also lead to positive events in one's life, such as an appreciation of smaller things or even becoming more goal-oriented. Improvements in healthcare, sanitation, food production, and national security have helped decrease death rates globally. Death is necessary to ensure the natural cycling of nutrients on Earth for new life to be created. Death is necessary to minimize or prevent overpopulation and to prevent living organisms to consume more than what the Earth can regenerate. Death is programmed in our cells as we produce free radicals as we try to live, and these free radicals result to aging and eventual cell death. And death is even programmed in our genes as small portions of this is cut away during each replication cycle of our cells. For a long while, we thought that the ancient Egyptians would decorate their tombs with images of their lives that they can take with them to the afterlife. But a recently discovered tomb in the Sahara Desert in Egypt has shown evidence that these images probably depict more of dreams and aspirations. Because despite the toils and hardships, or maybe because of them, the ancient Egyptians actually believed more and hoped for life after death. I hope you were able to learn something from our short video on the science behind death. If you did, I hope you can give this video a thumbs up and subscribe to our channel. If you have any comments, questions, or suggestions, please don't hesitate to message me, your resident Filipino scientist, in the comments section below. Thank you very much, and see you around!